Welcome all. So today this session we will take you through how to design the glass for safety, sustainability and aesthetics, and what are the tools that are available or it can help you to design when you are using glass. But whenever we use glass, it has to satisfy all the three requirements. It has to start with safety as first, and then with sustainability, and then how it's going to overall impact on the aesthetics. So the basic requirement for the safety is actually a guidelines which is given in National Building Code of India in the 2016 version. In fact, it is specifically requirement to glass. There are some demands being given there. Under sustainability, how to choose glass. So then we need to understand what are the kinds of glass available, how do we manufacture that, what kind of glass that we need to select for India, climate specific, and what kind of recommendations given in references from the codes, the energy efficiency codes. And based on all, we will be in the position to understand how to select glass for the building. The third important parameter which will be driving the both above safety and sustainability is the the aesthetical appeal. So how the building is being imagined during the design phase versus how it's going to come up with the product that has been selected, which is satisfying your safety and your sustainability requirement. And what are the tools available? How can you make your simple decisions can be made simple using all these above tools? So as a safety requirement, to start with, there is a very clear definition in NBC. What we are supposed to use it as a safety glass in your building. What it means is a glass which does not break under any likely forms due to human impact. Means even at a worst case, if there is a human impact, there should not be any kind of human injury, or I would call there cannot be any likelihood of cutting, which has to be eliminated in your building design. So in the case, so there is an access to glass by the occupant or the end user. So what kind of glass has to be used, in the sense what kind of processed glass. Here we mean processed glass is what kind of value addition we do on the structural property of the glass. So that's what been referred as safety glass. As per the definition of NBC 2016, safety glass means the toughened safety glass and laminated safety glass. So when we wanted to design a building as per the safety requirement of the codal, so there are 2-3 things we have to follow. One, the location of the glass. 2, the kind of process glass you have to use. 3, the structural testing or the assessment that has to be done to satisfy the codal requirements. So second important parameter will be your sustainability. So before getting into sustainability, means how to select glass, how to make a building energy efficient, how to select the right glass for the building, we need to have a small background on the history of the glass to understand it. When I say history, means what are the kinds of glass available, how it has been originated from origin to what we have today. So the basic is called the clear glass, which is a float glass which is manufactured. Then you can do the colors or tinted to the glasses. We can have a green, blue, bronze and grey. So there are 4 standard tinted glasses available in the market, which again been manufactured as per the float glass technology. So once the float glass has been manufactured, the basic float glass cannot give you any kind of performance impact. Means it cannot have an impact on your light transmission or solar factor or your U value of the glass, because the tints are given to give an aesthetical appearance, not for the performance impact. So when I have to achieve any specific performance, say it can be a solar control or it can be a thermal insulation, which is ideally called the low E glasses, I need to have a coating technology, which is the online coating technology or the offline coating technology. Online coating technology, as the name indicates, the coating is done on the line, which is a chemical vapor deposition process, whereas the offline, which is the magnetron sputtering. So the above coatings can be used to achieve whether it can be for the solar control or it can be low E. But the current technological growth has given a step forward where I can do both the solar control and thermal insulation in a single layer of coating. So what kind of coating I should be using it in India? Because these coatings are again has to be selected based on the climate responsive. I mean, ideally we have to take a decision based on the climate of the location. Say India or Asia specific or the global, there are different climatic conditions being divided. It can be of a cold climate, there is an intermediate, there is a warm climate and there is a hot climate. Whereas based on the climate of the condition, the kind of or the type of product used has to be different. For an example, if I take a cold climate or intermediate climate, where the product selection has to be done based on the U value of the glass or the thermal insulation property of the glass, because the outside temperature might be lower than your inside temperature. In that case, the challenge is to hold the amount of heat loss through my heaters which is placed inside the building. Whereas when I come to the hot climate or the warm and humid climate, where the condition is slightly different, say like an example as a continent, Asia, the outside temperature is always in majority locations higher than the inside side temperature. Means there is a lot of possibility of the external heat can transfer into the inner portion of the building. So how can I reduce that? Then you need a parameter called solar factor, which can be derived by the solar control glasses. So we have massively two different types of coatings. One is called the solar control coating and another one is called the thermal insulation coatings. Solar control precisely been used to achieve a lower solar factor, which is precisely can be a product for warm and hot climate. Whereas a low E or the thermal insulation glasses, where the intention is to reduce the overall thermal insulation value of the glass or the U value of the glasses, which is precisely can be used for the intermediate or a cold climate, where I have to retain the loss of heater efficiency. So again, as I said, India, we have two challenge and we need to have two important parameters which can be controlled by glass. One is the light, another one is the heat. If I divide the building energy consumption pattern, about 30 to 40% of the energy is spent on cooling the building, about 20 to 25% is spent on lighting or the artificial lighting, used for the artificial lighting. Rest has been consumed by due to the occupancy rate or any other kind of electrical appliances. So about 65 to 70% of the energy spent on every building is for the heat and light. On the other side, India as a country, we have an abundant light, or we can call it as an excessive light, or we have excessive heat in the same format. So what happens? I have a source which is able to give me more light and more heat. Other side, I am spending energy on light, again on converting the hot air into a cold air, which is ideally your heating, ventilation and air conditioning system does the job. So what we can do, how this envelope material can play a vital role. Today the modern buildings, majority of the buildings, the envelope became or the glass became an envelope material, which ranging from 10% even to 60%. So based on the building and its envelope requirement, there are three important parameters that we have to select. One is a light transmission, another one is a direct heat transmission, another one is indirect heat transmission. To get more detail into the light transmission, how it is going to impact the overall selection of the material or the comfort of the building. I have two cases in front of you. One is a plan which has very high light transmission. You can see the average lux level is about 4150, where I use a light transmission of the glasses at 89%. Against, I have a solar control glass whose light transmission is around 40%, and you can see an average lux level will comes to 292. So what we are trying to understand in this image is, there are tools available. So based on the window wall ratio, I can try to understand what is the amount of lux level on the floor plate. So for the same building, when I have an average lux level which is around 4000, so I would call this area as a glare area, and you can see the more yellow is mean there is a more glare area. So it is very easy with the today's technology, where I can understand the impact of light transmission of the glass based on the window wall ratio. So it's a very important criteria. Whenever we select a glass, the light transmission has to be the first criteria to be identified, because this is going to drive the entire comfort of the user. The more light, you're going to end up in a glare, and which you have to then solve the problem by using a blinds. Again, this blinds is going to diffuse the purpose of using the glass. The usage of glass in a building is for two purposes. One is to see through from inside to outside. Second is the natural light coming in. So the moment I have anything to block intermediate, we are going to disturb the entire design intent of using glass. So another classic example is, traditionally you will believe, when I need to increase the window area in a building with a current modern design, where we have even every homes as a French window, means ideally a bigger windows. And we believe that it will increase the energy consumption of the building, because traditionally the clear glass which is used, when you increase the area of clear glass usage, you are true, it will increase the energy consumption of the building because you are allowing more heat into the building through glass. But currently, there are high performance glass available, whether it can be your online coated glass or it can be your offline coated glass. For an example, in this case, you have an opening index. Ideally, I can say it as window wall ratio. I have a 16.4% as window wall ratio, where the electricity consumption is 4.2 kilowatt hour per meter square per year. When I increase the window wall ratio even to 25%, the electricity consumption has came down. This is because for the case 1, I have used a clear glass which has higher heat ratios, mean amount of heat that transfers from outside world to the inside the building will be higher. When I increase the window wall ratio, instead of using a clear glass, I have used a high performance glass which has an ability to cut both the light to an extent that we need plus the heat ratios. So this will give a very comfort environment for the inside. The left side picture clearly shows you the impact of very high light transmission. When we use in any when you see any building with blinds, it means ideally the glass selection is not done properly, or the glass has higher light transmission which is giving discomfort to the end user. So next step towards the product selection is your direct heat and your indirect heat. What is direct heat? Direct heat is nothing but the amount of heat transfer that are going to happen from the source directly into your space, or the frequency bandwidth between 780 to 2500 which comes from your source called sun, which is trying to enter into your building as such. That's called direct heat transmission, which we ideally call it as solar factor in glass. So to define you, the solar factor is sum of the percentage of incident solar energy directly transmitted and incident solar energy absorbed and re-emitted from outside to inside. So just to understand, as low as solar factor is good to go. The second parameter, which is U value, which is again, this happens because of the temperature difference between outside environment to inside environment. So the glass doesn't understand which is outside and which is inside. Only thing it understands is, as physics, I have to observe from the higher temperature side and I have to transfer it to the lower temperature type. So glass U value is 5.7 watts per square meter degree Kelvin for every 1 degree temperature difference. So for a condition, say outside is at 40 to 45 degree and inside my set temperature will be around 25 to 26 degrees. So there is a possibility to have a difference, delta T difference of about 15 to 20 degree. So the outside temperature has been absorbed by the glass, transmitted into it and into 20, because every 1 degree there is a transfer of 5.7 watts. So into 20 will be the amount of heat that transferred through indirect. So what will be the total heat that going to come into my building? There is a portion of direct heat and there is a portion of indirect heat. That's why we call it as total heat gain or relative heat gain. When you take the entire spectrum, whatever the spectrum after 780 to 250 nanometer and the heat that passed through, which is called the direct heat transfer, and then from near 2500 to 20,000, which we call it as far infrared radiations, which is also called indirect heat ratios, which is transferred into a building. So when I have to calculate the overall cooling capacity of a building, I need to calculate the two important parameters. One is called the heat comes through the envelope, another one is called the occupancy heat load. So the moment I go to the heat coming through envelope, that envelope carries two parameters. One is the direct heat portion and the indirect heat portion. It is very important in case of a glass selection, because when you take, for an example, when I take my solar incidence, which is my source value, which is at 500 watts per square meter. Similarly, I just for an argument for pan-India average, I have taken a temperature difference of 15 degrees. So when I have a clear glass, which has a solar factor of 0.73 in a double glazing, which is this, and I have an U value which is 2.8 for a double glazing format. So the relative heat how to calculate relative heat gain is solar factor into solar incidence plus U value into delta T. So in this case, if I take solar factor, which is 0.73 into the solar incidence, which is 500, which gives you 365 watts. Similarly, solar incidence U value, which is 2.8 into delta T, which is 15, which gives you 42. So sum of this becomes 407. So what it means, you can understand the impact that going to happen for your building through the direct heat and indirect heat. Here the direct heat ratio is about 85% and indirect heat is about 15%. So this is very important to understand. What will happen if I have a glass which has a coating to reduce the solar factor? So automatically I can reduce this to a certain extent. Similarly, if I have a coating which is called a low E coating, which have a tendency to reduce the U value further from 2.8 to 1.8, still the 42 watts can come down to less than 30 watts. It means there can be a drop of 10% in 42 watts, which is possible, 10 to 20%. Similar 10 to 20% drop, if I can do it by a solar control glass, there is a huge reduction on the overall percentage of heat that comes in. Just to make you an understanding, I have taken similar cases or several options. I have taken the same solar incidence value and the delta T temperature difference in a clear glass where the same value of 0.73 and 2.8, you know it's 407 watts. I have a low E glass or a thermal insulation glass, means ideally I have done a coating on a clear or a tinted base to reduce the overall U value. You can see the U value reduced from 2.8 to 1.8. The coating has an impact on the solar factor to a certain extent. It can reduce it to 10 to 15% because of the low E coating also. So when I do the same solar incidence into solar factor and delta T into U value, the overall heat comes to 312 watts. As an option 2, I have taken a hard coat or the online solar control glasses, which is a first generation glass, where the coating is being done to reduce the solar factor portion. Since it is a solar control coating, the U value you can notice it will be same like your clear glass, 2.8. But still, you see the 365 as came down to 170. So that is an impact that a solar control glass can be given. So you can see the difference from 407 watts to 212 watts, which is ideally drop in 50% of your heat coming in. What is going to impact because of this? The cooling capacity of a building is calculated based on, as I said, on the envelope heat load and internal occupancy load. The internal occupancy load going to remain constant based on any kind of glass selection you are going to make. So I have a portion which is the envelope heat load, which is ideally going to be the 60 to 70% of the heat load. So out of the 70%, I can drop 50%. Means my overall cooling capacity requirement, which is defined in the terms of tonnage of cooling system, can be dropped to a percentage of 30 to 40%, which is huge, because you have two kinds of impact because of that. One is because of your capacity reduction, you have a huge savings on your capex investment that you're going to do, plus the maintenance. For an argument, you're going to have a model building which has 100 tons of air conditioning versus a similar building which has used a high performance glass, which is going to have 70 tons of air conditioning. Means I'm going to pay the maintenance cost for 17 tons versus my comparative building or the base case building which is with 100 tons of air conditioning. So I have two kinds of coating, as I said. One is thermal insulation, another one is solar control. But the today's modern technology, which is ideally the offline or magnetron sputtering coating technology, I can reduce both the solar factor and the U value by the single set of coatings, by having multiple layers of coatings, which can bring even the overall heat coming in to 1/3 or 1/4. Even there are the possibility to play between 1/3 to 1/4. So in this example itself, you can see from the current base case of 400 watts of heat coming in, we can reduce the heat coming into 100 watts, which is ideally 1/4. Means the 70% of the heat load which is driven by envelope can be reduced. So ideally the capacity can be reduced by 50%. What the energy conservation building code says, based on the kind of building, your solar factor has to be at 0.25 and U value has to be 3.2 to 3 between the type of building, whether it is ECBC to super ECBC to UCBC plus buildings. So how this is all possible? How can I reduce the solar factor? How can I reduce the U value? So there is a generations of products being developed based on the market demand, climate demand or the design demand. So when the initial generation of products are started, the initial requirement is more on aesthetics. The designer wanted to have the building more visible, more shiny, I would say. So the focus is plus basic energy requirement compared to the clear glass. So because the clear glass light transmission, heat transmission are extremely high. So the market is looking for both the aesthetics and the marginal performance, whatever it is possible. So the industry having its technology called online, which is called chemical vapor deposition. So this technology as a technology has its own restriction to have more layers of coating or to add more types of products or more shades of product. So the market or the entire industry, glass manufacturing or the offline coating industry, moved from generation 1 to the generation 2, where the market started requesting for lower reflection products, and which they wanted to look very soothing, lighter, then which is in that case I need to have more number of layers of coating, which is I have a challenge in my old online coating. So we moved to the offline coating technology, where I can stack layers of coating onto the surface of the glass, which can help you to achieve what the market demand is. Then market wanted to have both the solar control and thermal insulation in a single layer of coating. Traditionally, whenever I use to achieve thermal insulation property, I use materials like silver to coat, which is called the single silver or the double silver or the triple silver layers of coatings. Moment I use silver, we know what going to happen when silver is going to get exposed to the environment. It will get oxidized. So these set of products are supposed to be used only in the double glazing format, which is generation 4 and generation 5. But the performance that these products going to bring in will be extremely high. Means if I take the performance achievement through the generation 1, generation 2 versus the 4th and 5th what we currently using in the market, the energy, the heat ratios can be reduced to an extent of 50 to 70% in the new generation products. So as I said, to give you some insight about how this been manufactured, the online or the offline. Online, as I said, it's the old or the first coating technology, I would say, which has a very limited challenges. Means it has a limited performance, or it can have a very limited aesthetics options. Means I can have every one base, I can have one product, or the performance can be of limited, say I can achieve a range of 50 to 60% light transmission with again 50 to 60% of heat ratios. But due to the development of green building movement in India, where we wanted to still reduce the amount of heat coming in, but not the amount of light coming in that case there is a huge challenge. So then I have to introduce more layers of coating. Online coating technology doesn't allow me to coat more than 2 to 3 layers of coating. So in offline, where I can add n number of layers, has given a provision to improve the efficiency of the product, or I would say superior energy performance is possible in this technology. Since I have a different provision to add n number of layers of coating, with a single base I can develop multiple shades of glass. Say from clear I can go to clear towards grey, clear towards blue, from clear towards green, or clear towards bronze or gold. So any colors is in today's technology, it is possible with one clear base, which can open up the entire scope for developing projects with more aesthetical appeal. And all these products are temperable, means whatever I produce can go for any kind of value addition. It can go for a tempering or toughening process, it can go for a heat strengthening process, it can go for a lamination, it can go for a bending, it can even go for a ceramic printing or end with a double glazing format. So any of this value addition, it is possible in your offline coated products. Because currently the durability requirement for whether it's online or offline are very strict and stringent as per the norms. So it has to pass through a multiple durability process like your Ericsson brush test or your Faber test to understand the complete durability process. So here I'll show you a small video how the coatings are being manufactured, because even when I take you to a factory, this is all done in a closed environment, which is not easy for us to visualize it. So for easy to understand, I will take you through a small coating video which has a voiceover on its own to brief how the coating is done and what kind of coating is done possible in online and what kind of coating is done in offline. And it take you through what is the environmental conditions that I have to take through my glass if I have to do the online and I have to offline. So welcome back. So after the coating, you might have a clear understanding on how the coating is happening now. As the video says, your online coating happens when the glass is getting manufactured, whereas the offline coating is happening after the float glass or the basic glass has been manufactured, I have to take it to a separate line for a coater as you've been visualizing through the video. We have to create such kind of an environmental condition so that the target material gets better onto the surface of the glass, and I can do n number of layers. Ideally we can do about 18 to 24 layers of coating possibilities in India to achieve a very high performance requirement from the market. So what we mean high performance? How can a common designer can understand what is mean high performance? It's very simple to understand. If you can see through this, there is an online coated glass whose light transmission ranges from 30 to 46%. There is a very important parameter which you should be able to understand, which is called the spectral selectivity. It is nothing but visual light transmission by solar factor. Visual light transmission by solar factor. So when I divide the light transmission 30 by 46, which comes to 0.65, means this glass has spectral selectivity which is 0.65, means the light transmission of the glass is lower than the percentage of heat that is going to transfer into it. So the challenge in front of the glass manufacturing is, how can I improve the selectivity of the product without increasing the heat transmission? So if you see the next generation of the products, where I am able to achieve 46% light transmission with 46% heat transmission, which has brought the selectivity to 1.1. 1 to 1.1, the basic generation of the product. Mean, whatever the light transmission, say I can have a product which is at 67% light with 67% heat, 50% light with 50% heat, 35% light with 35% heat, or even 20% light with 20% heat. That's called the first generation products. Then there is a improvement in the product, where market was moving towards the silver based glasses, which is ideally a single silver or the double silver products, where I can increase the light transmission of the glasses but not the heat. For example, in this I have retained my light transmission as same, but whereas I am able to reduce the heat transmission to an extent, where it improves the selectivity ratio to 1.3 from 1. Second, when it's a first single silver, so the market moved toward a further improvement in the selectivity. So we introduced a double silver coated glass, mean ideally I have 2 layers of silver as a part of the number of layers of coating, where you can see I can increase the light transmission, but still I am reducing the solar factor. So the selectivity ratio comes to 1.82. Further, the next generation glasses which we started producing in India, where still you can retain the same light transmission and further reduce your U value, solar factor. So the selectivity has gone to one of the highest in the world, which is about 2.1. So this kind of products are called high performance glazing, where I don't allow more heat coming in, but still I can allow more light coming in. Again, the percentage of light requirement has to be designed based on your building requirement. So the third important parameter after safety, sustainability, which is the aesthetics. So what I can do for aesthetics? As a dreamer, as an architect, as a designer, you will have a particular color during the design phase of your building. But when we have a safety and performance which can be visualized, which can be tested, which can be understood in various formats, are we making a wise decision in selecting glass? When it comes to aesthetics, it becomes a challenge. What traditionally we will do? We will go for a mock-up. As you see here, you can have a different mock-ups done. But what is the challenge in the mock-up? The mock-up is not actually making you to visualize the real condition the building going to come in reality. Because when you do mock-up, the entire environment, the other environment of your building is kept open, and you will be having a mock-up at a certain height, say second and third floor. So the way you see the glass, the way you see through the glass, sometimes the higher light transmission glasses, you will be seeing through the environment of the building through the glass, and that gives a improper notation on the light in the color of the glass. And the mock-up sizes are quite small. You can do a mock-up of say around 6 feet to 4 feet or 1800 to 1200 sizes. When compared to the size of the building, the mock-up sizes are small. And the product looks very lighter because the environments are open up. And it's a very costly process because you will not be able to select with 1 or 2. You might have to try with at least 4 to 5 options. Then you have to try with the different manufacturer shades. So it will increase overall cost of your building by doing a mock-up. Okay, even by doing all this, spending money, even though it's a costly offer, is it going to answer your question? Do my design aesthetics is matching with the building when it is going to get completed? No, we would say no, because as I said, the environmental conditions are different when the building is completely glazed towards the end. So how can we do it? Traditionally you might be doing a rendering, but the challenge in rendering is when you do a rendering, you may render the product or you may render the building with a color that you like it. But when it comes to the glass, because of the transparency property or because of the reflection property, the way the same color looks, it will be different. So what is the way forward option? There are no physico-realistic rendering solutions available with the manufacturers, where you can see the picture in the left hand side, where ideally you can try a building with the product that you wanted to see against what this same kind of a building in artistic to view you might be rendering. But in reality you cannot get the picture what you are seeing in the right, because the colors used in the rendering are comparatively not realistic. Whereas in the left hand side, when I do a physico-realistic, I am trying to imitate as real as the environmental conditions, the lighting conditions or the source condition we call, and the glass properties from the glass. Ideally the measurements being done for the product and the same measurement being integrated into the software, where the software renders it, the actual product, and then it gives you what is going to be the color. This can be developed with multiple conditions, like whether you wanted to see the building in a cloudy day, sunny day, longer view, long shot view, or the very closer view of the building. So this as a tool, there is a tool called GlassPro which is available, where you can do the same process in a very simple steps. To just to make a first impact on the color, you can go to the Cubus, where you can try with the different colors or the tinted options available with the different high performance products, and you can select 3 or 4 options from that. To make you more clarity, this selected options can be put into an urban scene, where it is called a template building, I would say, where you can put the selected products and you can see how this building or how the products going to look in a massive scale manner. But still, if you are not able to understand what will this products will happen along with my other building materials, or how my design going to match with the color of the glass I have selected, there is an option 3 available where you can do it on your real building. So we will take the basic drawings, modeled drawings, where the product values have been integrated, and then the rendering has been done, and the final output can be presented to you.